So my BA and MA in math were largely dedicated to the mathematical study of brains and therefore, perceptrons and connections, what would now be called machine learning. And in parallel, of course, I was in strong AI, did natural language processing and symbolics. And so I teach this stuff, cognition and computation, natural language processing, but I could never get anybody interested except nerds. GPT-2 was actually much better than ChatGPT. But suddenly, when ChatGPT came out, everybody wanted to talk to me about AI. This taxi drivers and bartenders and people at the cleaners wanted to talk about AI, and so that was really cool. And so I had an idea, and my idea was that these things have been trained on more data, more linguistic data than all linguists who have ever lived could have been aware of, much less studied, if they had 100 lifetimes. And to the extent that we think they succeed, it's because a cooperative viewer, namely us, approves of the way in which they mimic human output. Because if they can't do that, we just think they're not interesting at all. Right? Well, the question is not whether AI understands language or has language or can think. All of that's false. The question is, can they help the linguist? Can we trick them into revealing some patterns? Because what linguists do is look for patterns. And they often suffer terribly when they look for patterns. They spend years without noticing a certain pattern. Then they notice it, they're not sure of it. Then they think, yeah, that might be right. And then they are convinced that it is right. And then they feel very bad and stupid that they didn't notice it for all those years when they were looking for it. Can we get them to help? So we put together a team. Can these things be useful to the linguist? And this is a book. It's only 107 pages. If you need it, let me know. The idea here is not to look at this or that model because the models will change. The idea is to set up a system in which we can train graduate students for how to think about using these things to help the linguist as a co-pilot. The co-pilot should never sit in the pilot's seat, but can we make life easier for the pilot? And we took this group of guys, Tiago Torrent, Thomas Hoffmann, Lorenzi, and this other guy. We took two particular areas. One was frames and FrameNet, because as you know, FrameNet is quite sparse. There are only 1,200 or 1,400 frames in FrameNet 1.7. Everything having to do with tourism, for instance, is not in there. You get big things like cause motion, but a ton of frames that are simply not in FrameNet because of the meticulous, careful, time-consuming work. So for FrameNet, we wanted to ask things like, hey, can you propose new subframes for event, attribute, entity, right? New subframes for gradable attributes. Can you propose new lexical units that we've missed for various frames? If we have a frame in Japanese FrameNet, how can we recruit that and exploit that to help us in Swedish FrameNet, right? And we also said, hey, constructions. Can you analyze propose constructions? Can you give us this and that and the other? So discourse constructions, for instance, I'll just tell you the example. We told it to give us the construction known as the knock-knock joke. And we told it to give us a discourse construction for apology. And we asked it to give us an analysis of the noun after noun. Like he did this day after day. Notorious because you can get confounding things like the day after morning, the morning after morning coffee was banned, it was restored, which is not a morning after morning, right? Can you trick it? Well, easy answer is you can trick it if you lie to it. You tell it there's a construction of a certain form, it has this pattern, and it'll generate 100 examples in that mistaken pattern. But it turns out to be quite good and quite useful if you know how to prompt it. So we wrote a book and we made a site. We made a site in which we explain how to do prompting for constructions and frames, and we invite your input. This is a clearinghouse for how to work with stuff. This is where we trick the car John crashed. This sentence implies that John unintentionally crashed the car because we lied to it about this construction in English. We present in a number of publications how you can get it to provide stimuli for experiments, for things like magnitude estimation of acceptability on frames and constructions. So here's, for example, what it does with noun after noun, the model train chugged from station to station. This is a true NP, blah, blah, blah. We pay a price for price wars. This is not an instance. Price wars is a compound noun, blah, blah, blah. Yeah. So we prompt for FrameNet. We have an elaborate methodology. It's in the book. We prompt for lexical units. We prompt for and we tried this on proprietary and open source. We distinguish different kinds of stuff. We look at transformer architectures. We train people in how to do this. And here's the site where you all together and help us out. But now, new stuff in our little tiny few minutes. There's a case for data labeling automation in FrameNet. And that is, it just takes forever for human beings to do this. So can we give them some help? And we want multimodality. So we have, this is Marcelo Viridiano's work, and he's an author on this, where we have a database, took 13,000 news articles to have both text and image. You make two different pipelines, one which is visual, one which is textual. The textual one is run through a system called LOM, which I can explain to you. It's been proposed in the last couple of years. We have steps for human validation at each point. In the image system, we have a system that takes the image, proposes entities, makes bounding boxes, does entity connection. So here's just an example. You present it with something like this. It finds a title, an image, and an excerpt. On the text side, it extracts frames, attributes frames, decisions alone. And I'm not going in this crowd try to talk about what a frame is, but if you have a tourism frame, which has got a place and the tourists and so on, it's what it does. It says, all right, I pick out the frame of age and appropriateness in the life cycle. The visual picks out the people, and it puts them together into, we tried this on many different models. The one we cluster one is Gemma. And just, you are a multimodal visual analysis expert, assisting with the creation copilots, right? Not pilots. You will be provided with a photograph and tell it what to do, blah, blah. And it looks for entities in the visual stuff, and it lines up an object list, and it connects it to the text, and then proposes connecting it to the text through grounding Dino, and it proposes for the FrameNet builder
possibilities for frames that we might actually like to attribute multimodal frames. And it comes to you, and you're the frame net extender. And so that's your copilot. I'd like to point out that we are now trying to extend this to copilots for gesture research. So here's Kate Carter, my student who just graduated, and this is she 6 days ago at Nijmegen at the gesture conference presenting her system. Her system relies on Gemini, and she built through a Google API a pipeline that will go through and try to recognize gestures. Here's her preferred parade example.
Nominated. So
Do that again.
I was the nominated. So
It's Christoph Waltz saying I wasn't nominated. I'm an American, so I would say nominated in the same sort of way that I would say classificatory instead of classificatory. But Christoph Waltz says I wasn't nominated, right? And the system picks out co-speech gesture. It's extremely good at timestamping. Why not? It's got it frame by frame. Sometimes in a high resolution, it says I wasn't nominated. It talks about his body. Now, hot out of the oven, there are lots of other models that we're now running. And the important thing here is not the particular model. They differ, but the models will change. We know how they work. It's a ton of vector calculus, a ton of linear algebra. It's brilliant, but this is easy math, right? This is sophomore level mathematics. We know how it works, we explain how it works. The question is, given that you know how these things are going to work mathematically, what's the right way to prompt them and where are you likely to make a mistake? So they have strengths and weaknesses. The idea is to make an AI to a volunteer in which the copilot proposes gesture recognitions and Python bridge and so on. This is all in place and you can get it from Kate's website. Now, Kate's work focused just on the body and hands. So I, a week ago, asked it to do the face, perform a detailed analysis of the speaker's facial expressions, research and gesture to analyze, blah, blah, blah. And it does. Instantly, of course, the fleeting eyebrow raise adds a nuance and surprise as well. All things. So you can evaluate this, but I will move faster to say, you may know that a few weeks ago, well, you may know that I direct Red Hen Lab, whose legal protection comes from the University of California President's Office legal team, mainly Section 108 of the US Copyright Act. A few weeks ago, Judge also, who happens to be the federal judge to which they send almost all of the AI cases because he seems to know what a computer is, ruled that science is good, but stealing is bad. So if you have the right to see any intellectual property like Alan Chinky's Handbook of Gesture Studies, which I own, right? If you have the right to see it because you got it from a research library, you owned the book and you scanned it, you had a digital copy, whatever, right? Whatever. Then using it to train AI is exceptionally transformative use and entirely legal under fair use in the United States. Bravo. But that if you stole it, you are gonna be hurt bad. So the people who actually stole, and he said, if you stole it and then later on bought it, that doesn't stop us from punishing you for having stole it. So Alan Chinky was in the audience when I did this, and he said, no, he was not going to stone me for this. I fed, see, when ChatGPT came out, it was a dog and a pony show. It was trained on the internet, so it was full of nonsense. Don't let that media meme stick in your head. You can train the thing on holy texts like the Handbook of Gesture Studies, and you can say, By the way, I own a lot of these, but let's just stick with this one. And you can say, if you don't find the answer in the holy texts on which I have trained you, just say you don't know. Which means the AI doesn't know who George Washington is, right? But that's okay. So I trained it on this, and I gave it just this prompt. Use the methods and theories and tools from the from the uploaded handbook to analyze thoroughly the uploaded 6-second video for gestures, including face, hand, and body. Of course, off it goes. It reassures me it's going to do this in the tradition of Adam Kendon and David McNeil. The manual gesture, kinematic analysis, which we're familiar with, preparation with timestamps, with preparation with stroke, what the hand shape is, a flat hand configuration, orientation, the motion, synchronization, stroke is perfectly timed to coincide with the stress. So we'll go with the key word in the utterance, nominated, this tight synchronization is carried, blah, blah. The retraction, semiotic classifications on Kendon continuum, the metaphoric gesture, lack of agency, helplessness, it's not my hands in the situation as it stands. It goes into the facial action coding system, and picks out the parts of the FAC as where the things have moved and hasn't moved. So lower face action, upper face. The ironic resignation, speaker's body in relation to the facial gestures, speech, hands, face, pragmatic knowledge of reality. This result is a communicative act of remarkable efficiency and sophisticated blah blah. Now, the point is, I hope you find problems with this. It's pretty good, actually, I have to say. I showed this to gesture studies. But that's not the point. The point is that the AI goes through and ponies this up, sorted into an Elan file for you to look at. You get all of this. And then if you want to correct it, you don't just correct it right there. You train it. You come back and say, you made a mistake. I'd like you to do it the other way next time. And you adjust it, you iterate, you do this, and you do this. I suggest you use SEAL. This is only about 3 weeks old, but it is an AI system for doing this kind of training. Now, even hotter out of the oven, I want to mention something that's, we all have to kind of take up. And that is the highly contested and controversial idea of synthetic data. So I have a lot of lab data on speech and gesture. And one of the problems is it's ecologically invalid. And you know this because for acid and copper in the laboratory, I feel that it operates the same way there as it does somewhere else. But human beings are a social species. The largest treatment in any behavioral experiment is that the subject knows he or she is in an experiment. This is not normal behavior. There are experimenter effects. We have large replication crises. I've had real gesture researchers, of which I'm not one, although David McNeil found me in 1983 and explained to me why gesture was such an important window on mine. I was completely convinced. I've had real gesture researchers perform gestures for us to film and to teach people on gestures. And so that's also not ecologically valid. But synthetic data is or can be a statistical compression of a real data. So when the AI slop speaker with AI slop synthetic expression and synthetic gesture is speaking, it's actually grounded in ecologically valid data. You can get as much of this as you want, and I can talk to you about how to do it, what the different models are, and how to make it, so on, how to get the voice, blah, blah. Yeah. You can get as much of this as you want, and then if you have your Copilot for linguists, you can give the data to the Copilot, and it can analyze, come up with hypotheses, say, I think I found this. This is while you're in Rio looking at the beach. And if it comes up with something that's actually interesting, then you can do the work of running an actual behavioral experiment. Then the pilot is sitting on top of a proposal from Copilot that's been through a ton of data. You might do brain imaging. I recognize how controversial this is and how dangerous and scary it might be, but this is the world that we live in. It is what it is. It's not just that I have undergraduates, graduates, and postdocs who are doing this all over the world and right in the people across the street from me at Shaker Heights High School, I mean the 16-year-olds, found me and said, can you teach us how to analyze language, speech, gesture with AI for our science projects? There are 15 of them. I said, okay. So the 16-year-olds are doing this, right? This is the world we live in. It's very easy to make this kind of data extremely right? It's an article in the New York Times about all this kind of stuff. So my point here, and I think we've got plenty of time, is human beings work with distributed cognition. We've always worked with each other. We've always worked with tools. We work in networks, and when technology advances, the question is, where does the human being relocate in the network of intelligence? So where does the linguist relocate in the network of doing research? This is a question I ask you. This is sometimes called co-intelligent. That might be a pompous, presumptuous, vainglorious word. Call it whatever you want. Maybe it's not intelligence, I don't care. But the question is, what is the future? We're working on Copilots for linguists. We've been working on it for a few years, and we would be very grateful for your help.